So this question, we're given a monomer, and it says describe how this monomer forms a polymer. So this monomer that we're looking at here, because it contains a carbon-carbon double bond, what's going to happen, if I zoom in a little bit, is one of these bonds will split, and then it'll form new bonds that allow it to join onto the next monomer in the sequence. So I'm going to put that into words here. So I'm going to say the double bond breaks open, new bonds are formed which allow the monomers to join together and make a long chain. There's 2 marks in there, one mark for the double bond breaking open and this idea that the monomers then join together. Just out of interest, because it's going to help us in the next answer, when that happens, I'm left with a carbon-carbon single bond. I've still got a chlorine, a hydrogen, a chlorine, and a hydrogen, and then I've got this new bond forming here. So that would be the polymer that would form from that structure. And the next question wants me to identify what the polymer would look like, and the only one in this table of choices that matches that is this one here. Option B is the polymer that would form. Carrying on, separate samples of these 2 chemicals are shaken with bromine water. What would be seen? So remember here, this is, the fact it's an ene means it's an alkene and it's got a C double bond C. And this one here, because it's a long chain, that double bond, as you've seen, has gone. So this one is carbon single bonds. So this one is, we describe as saturated, and this one we described as unsaturated. And we add bromine to this. The only one that reacts is the unsaturated alkene with the double bond. So both mixtures remain orange is not true. Only the dichloroethene and bromine water goes colourless, that will be true. Both the poly and bromine water goes colourless, no. Both mixtures go colourless, no. So the right answer is option B. Here we've got a description of the equation, and it tells me that we also get hydrogen chloride being produced. So hydrogen chloride is HCl. If you didn't know that, you can work it out. Go to your periodic table. You should know that hydrogen is a positive ion and therefore wants to make 1 bond. Chlorine or chloride ions are in group 7 and therefore they have a negative charge and also want to make 1 bond. We cross those over, so you end up with HCl as a formula. If you check this, the fact there's 2 marks means we do have to do something else here. So they want us to balance it. So again, if we just check, zoom in a little bit more. So here we've got 2 carbons, we've got 4 hydrogens, and we've actually got 4 chlorines. There's 2 there, and we times it by 2 is 4. On this side, we have got 2 carbons, we have got 2 hydrogens, and we've also got 2 chlorines. So my hydrogens and chlorines are not right. So all I need to do to make that right is put a big 2 in front of that. And I'm going to get 1 mark for the number 2 and 1 mark for the HCl. Next one, this polydichloroethene is used to make food wrap and help keep food fresh. One property the plastic must have to do this. So there's lots of different answers here. For example, you could say it's flexible. And why does that help? Because it will wrap around the food. So that's a good use. Other thing you could say it's a non-toxic material and therefore it stops food becoming poisonous. And the other one is it's unreactive, and again it doesn't react with the food. It will not react with the food. All we need to do here, I've given you 3 different answers. All you need to do here is give one property, so for example, flexible, and then why that is good, explain it, it wraps around the food. Okay, this one is a calculation, and we're told that this process converts 96.5% of the dichloroethane, and it wants to know how much has not reacted. So first job is, out of 100%, we have got 96.5% that is reacting. So what we have to do here is to work out the bit that's unreacted, is take those two numbers away from each other, and that's giving an answer of 3.5%, and that is the unreacted. Okay, and then all you need to do is, we actually started with 500 tons, so I'm going to times that by the 3.5 over 100, because that's a percent. So times by 500 divided by 100, and I'm getting an answer here of 17.5 tons, but I want it to two significant figures. So if we just check 1, 2, 3, so the third figure is a 5, therefore I need to round the 7 up to 8, and I've got 18 tons of the chemical. 1 mark for working that out, 1 mark for working that, and then 1 mark for working out this answer to two significant figures.